Yeah, now we wait for the 2 minutes. Yeah, maybe their friends is coming in. Yeah, hope everyone is good. Yeah, since yesterday, 2 hours lecture, and then with the morning, 2 hours lecture. Today's Walker is not very good. Yeah, I want to sing a song for you all. I think it's hard. Okay. Today is about quantitative. Yeah, yesterday is about qualitative. Yeah, we wait for the other 1 minute. Yeah. Uh, okay. Good afternoon. Yeah, all of you. Research methodology module 4. Yeah, for the social sciences. Yeah, social science. Yeah. Yeah. Today is about the quantitative data, result, and discussion. So by the end of this presentation, students will be able to identify and differentiate type of statistical analysis, understand when to apply the descriptive and inferential statistic, interpret the common statistic output, and apply basic quantitative data analysis to both numerical and category, okay, qualitative data. So what is a quantitative data analysis? Yeah, so the quantitative data analysis is focused on which the process analyzing the numerical information to the better understanding relationship between the variable. Yeah, we look into the variable. Yeah, some is a two variable, some three variable, some is many variable like vector analysis. Yeah, and it involved either the category or numerical data. So the focus on the statistical analysis is better assess the trend and patterns. Look into the trend and patterns. It is a big difference to the um, to the qualitative, yeah, totally different, because quantitatively into the patterns, qualitative look into the current scenario, the practice or as the current scenario of the situations. So they supply in the both category. First is the category is a quantitative data like a gender, occupants, blood types, yeah. Numerical is like age, blood pressure, heart rate, and so on. So most analysis are performed using the statistic analysis like STAT, SAS, SPSS, yeah. Mm. Type of statistical analysis they divided into the two. Yeah, if we go to the SPSS, also have the two type. One is the descriptive statistic. The other one is inferential statistic. So descriptive analysis means by the summarize the main feature of the data. Yeah, summarizing. We look into the what um, into the like mean, mode, yeah, standard deviations, and so on. And inference statistics allow the making the predictions or generalizing about the population based on the given sample. Like in a group of 100 patients, a researcher want to know if assessing daily lower blood pressures, inferential statistics, yeah, will help determine if the result is applicable to the general population. Yeah, so we look into the what uh, relationship of differential among the respondents. So in the descriptive statistic, they have the four type. The first is a central tendency. Is describe the center of the data. It represent mean, medium, and mode. And secondly is a dispersions statistics in the descriptive analysis. It's a spread of value in the data set. It look like the data type of range, variance, and standard deviations. Thirdly is a location. It indicates where a specific data point fall in the distributions. Yeah, it look like the data is like quartile. Yeah, daily, delicates and percentile. This is some sort of the location of the data. And proportions and rates is summarize how others something happens in like proportion, rate, prevalence, incidence, odd ratios, and relative risk. This is a few type of the data of the proportion or rates. Yeah, normally we will call it is a rate data. Yeah, four types in descriptive statistic. So we go one by one. The central tendency, the first is about the mean. Sure, everyone knowing. Mean is average value of the data set. Yeah, central tendency is a basic. Mode is the most frequent value in the data set. Mode, for most, which one is more frequent? Okay. Medium is a midpoint or medium value in the data set. So as long as we are in the group, yeah. So we have to group it and then to analyze. Easy, very easy. Yeah? I think during the times I was using the SPSS, I have to key in all the command. Yeah, in the old version, I think the first or second version of the statistic SPSS analysis. Everything have to do it in the command. And later on, they have the spatial new version until now. Yeah, the version I think starting in version 4 or version 5, yeah, is no much command already. It's a very simple. We just click. Yeah, in a minute, within a minute, the analysis result will come out. That's why sometimes I talk to my students. Mhm. Yeah, so I always talk to my students. Quantitative analysis actually is a very simple. Yeah, once you get everything on, especially your data, you can run and key in your data into the SPSS, and you just a fingertips click within a minute, you can get it data. And then within a day, you can do the analysis and come up with your chapter 5 or chapter 6 already, the result. Yeah. If you're not expert in SPSS, is no problem. You can hire friends or some consultants helping you, but you have to understand why you operate using this method. Yeah. Some of my friends, my students are quite old, not older than me. Yeah, but last night is older than me. I was older than me. Yeah, they are data because they are 50 something. So when talk to the SPSS, they can't understand it all. So we hire the consultant from consultants from the students also, helping him to run the analysis. Yeah. Why I saying the important things you must understanding why you use this analysis, because when during the Viva section, the panel will asking you why you use this analysis, why you use that analysis, why you look no doing the other analysis. So this will be the the things you're going to answer. In the dispersion data set, we look into the range and variance. So the range is show the difference between the large and the smaller number in the data set range. Yeah. And then we do have the variance. Yeah. Variance that demonstrate the how closely the data set is spread in the relation to the mean. Yeah. Normally, when we talk about the uh, uh, mean, sometimes we need to have the variance over there. Yeah, statistics modeling or computing variability. Yeah, we use it. Yeah. Mhm. For the next dispersion is a standard deviation. Yeah, this data also will appear during the data analysis. Yeah, especially after the mean, we will put on the standard deviation or variance. Okay. So the standard deviation is a square root of the variance. Yeah, a value close to the zero representative, the data points are close to the mean. Yeah, so the more accurate of the uh, uh, standard deviations toward the mean, meaning is a better result of the mean. Yeah. So for the evaluating data spread around the mean. Yeah. Next is a location. These locations is about the what percentile. Yeah, value below which X% of the data falls. When analyze the individual data point in the relation to the data set. Yeah, that's why somehow your descriptive analysis, you're not only putting the frequency over there, you have to put on the percentage. Yeah, look into the percentage for each elements in your study. Quartiles. Yeah, quartiles is a device data sets into the 4 equal parts. Yeah, like quarterly. Yeah, 25%, 50%, 75%, and 75%, and so on. Yeah, this is where analyze the data with the outlier. Yeah, the different data we're using the different set of the analysis about the location. I think normally the student will using the location like a percentile to represent the data, yeah, distribution. At the location also we have the delay ties. Yeah, this one delay ties is a look into the situation 10%, 20%, yeah, 40%, 60%, 70%, up to the 90%. Yeah, similar to the quartiles, yeah, quartiles, because this one look into the small percentage is a 10%. Quartiles is a look into the 40, 25% of the range. Yeah, it's so-called location data. Next is the rate. Yeah, proportions is first is the prevalence. Yeah, prevalence is a proportions individual in population who have the condition at the specific point in time. Yeah, when we use it is to describe how common a disease or conditions is within a population. Okay, rate. Yeah, normally. Yeah. Okay, risk ratio is a in cohort study or clinical tries to compare risk between the two groups. Yeah, normally risk ratio, but we seldom using this. We normally use a ratio. Yeah. Next is the proportions rate also is the odd ratios. The ratios is the odds and outcome occurring in one group in the odd in other group. Yeah, comparing the group. Yeah. Okay. Case control study or when this outcome is rare. Yeah. We look into the specific rare issue. Yeah. Can use it. It's a control study. Yeah, like study for those teachers and those normally reference statistics. The first is the hypothesis testing. Yeah. When you have the hypothesis, you must have the statistical analysis. Use across if there is enough evidence and reject the null hypothesis. Yeah, you are no worry when our hypothesis null is rejected, yeah, or accepted, yeah, because case study will be different from the others. When you do the data correction, you study it by the previous study, yeah, saying A has a strong relation with the B, but when you come to the analysis, you are no, it's accepted or rejected. It's no problem because a different type of the case study will generate the different type of the data. Yeah, this is I really appreciate somehow we reporting the true data even though there is a rejected. Yeah. Mm-hmm. Estimation using the sample data to estimate the population parameter. So p-value, yeah, normally we must have the one standard is a p-value, yeah, where we refer to if either the more or smaller or larger from the p-value. Yeah, p-value somehow is commonly used is a 0.05. Yeah, if the p-value demonstrate the probability that the observed result not more than extreme could occur if the null hypothesis were true. Okay. So commonly the p-value is we can consider is either is a 0.05. So meaning that is a 5% change in the finding a result as extreme as the one observed. However, the data V value is not fixed. It can be changed, depends on the study design, yeah, sample size and potential consequences of the false positive. Now, very easy. You just choose the analysis either in 2 tile, 1 tile. They already come out with the p-value for you. Yeah. And then p-values as an example. A researcher is studying whether a new heart medications lower blood pressure compared to the placebo. So after analyze the data, they find out P is a 0.03 and alpha is a 0.05 set by the researcher. Yeah, we can set up. Normally, if the since a P is a 0.03, which means a P less than 0.05, the result is a systematically significant. Yeah, we must make sure it's a less than 0.05. This means there is only 3% probability that the observed differences, yeah, or the more extreme one occur of the change of the medications had no true effect. So researchers reject the hypothesis null and the new medication cause no differences. Okay, so conclude these new medications likely lower blood pressure. Okay, so it's important we're using the p-value to running our analysis, yeah, to get the p, yeah, alpha and p is we can set up, but p is normally is based on the type of analysis, yeah, it's a significant data. So confidence interval. CI, we call it as a confidence interval, provide the range of the value. The likely contents of true population's value, such as true mean or proportion. So based on the sample data, yeah, we try to see this. Interpretation depend on the confidence level. Yeah, confidence level is commonly 95%. Okay? But look at this. A 95% of the confidence interval means that if we repeated the study many times, 95% of the interval could contain the true value. Okay? If let's say you put on the 99% as a CI value, it uses when the consequences of wrong conclusion are high. It provide the greatest certain, but the interval will be wider. The other one is smaller, commonly is about the 90%. It means the 90% of CI it use or narrow range is accepted and quickly decision is needed. So when we do want to run too many times of the analysis, we can set up the commonly is at the 90. Yeah, meaning more other people can accept it. Yeah, compared to 95% of CI. So we look at this example. This is a statement from the Guang and Zhang. Evaluate the association between the ideal cardiovascular health (CHV) metrics. Yeah, it's a heart disease, and risk in the cardiovascular event as well as the mortality. When look into the smoking as an ideal CHS metric, yeah, CHS refer to cardiovascular health metric. They found that the risk ratio was RR, yeah, reading. When you got the analysis, they will come out with the RR, yeah, 0.54. If 0.54, we use the 95% as a confidential interval, yeah, with the P is a 0.001 for the cardiovascular mortality. It means when we try to interpret the data, we get a set of data from the SPSS. Ideal smoking status non-smoke in the associated with a 46% lower risk of dying from the cardiovascular causes. This is shows by the risk ratio RR is 0.54 with a 95% of confidential interval from the 0.38 to 0.377. Yeah, so meaning we are 95% confident that the true effect falls in this range. Yeah, they want to convince people on the study. They use the confidential interval analysis. Yeah. Mhm. So, in the other one side is inferential statistics. Yeah, is a Pearson correlations coefficients. Look into the relationship. Yeah, Pearson correlative coefficients, a statistics test, then measure the strength and direction of the linear relationship between two continuous variables. Yeah, look into the two variables. So range from the -1 to +1. Yeah, I hope everyone you are here, you try to read more about the statistical analysis, yeah, in the textbook. Yeah, now easy for you to get through the data or information from the website. Yeah, especially for those PhD by research and master by research, you must have the very strong methodology. Yeah, once you using the wrong methodology, include the statistic analysis, to bring your thesis failure. Yeah. So range from the -1 to +1, yeah, is R. R is a relationship. R equal to -1 is a effect, negative linear relationship is a negative. Yeah. If R equal to +1 is a perfect positive linear relationship. Okay, there is a no linear relationship if R reading is 0. Yeah. Once you trying your data, already key in your data and you running the analysis, all this will be occur to you to look into the either the positive or negative. If the negative, no problem. You just highlight why negative in your study. The next is the example. Yeah, is Ramus 2018 study whether regular exercise influence resting heart rate (RHR). So they reported correlation is R minus 0.36 between the baseline RHR and charge of the RHR after the participating in the different type of sport. So this indicate the individuals with a higher baseline RHR tend to show the decrease in the RHR after participating in a sport. Yeah, so this is a conclusion. The result coming in, we must be explained. Yeah, so actually, for sir, I think quantitative is very simple. Yeah, very easy. Yeah. Inferences numerical, the students are using the t-test. Yeah. T-test compasses the mean of the two group, yeah, of the one group to determine if they have the significant differences like gender. Yeah. Gender now we have two, male and female. Some of the study in other country, they have the other type of gender. Yeah, somehow go to the three. Yeah, if the two, we use the t-test. If you categorize it into the three types, you have to use the ANOVA. Okay, certain consumptions must be we need to use of t-test. Normally, is a normality test. Yeah, we're running the normality test. Okay, for the scholar here, yeah, I have to mention two things. Yeah, it based on the scholar practice. Other people saying, the data you have to running the normality test. Yeah, then you decided to use non-normality for the t-test and ANOVA. There is the other one. Yeah, if the normal, you can use a t-test or ANOVA test. Yeah, this is running the normality test before you decided, yeah, to use the what type of the test to look into the differences. Yeah, but the other hand, the other group of the scholars saying, if I follow the proper procedure to do the data correction on the respondents, especially respondent random and so on, meaning my data is a normal. Yeah. So when we come to this stage, yeah, as a sir, I can accept two because of what I learned from my previous supervisor, yeah, and then previous reading. They the scholar have the two idea. Yeah, one is you running the normality test, then you decided the next either t-test or SCAR1, how to call it. Yeah, if you Google the statistic SPSS, they have the other non-normal data. Yeah. Mm. It depends. Yeah. So normally, if my students, it's for the secure, if they get a internal or external are very expert in SPSS, they are encouraged to use the normality test. Yeah. So I advise also, if you don't want to jump into this gap, I call it as a gap, you running the normality test. Yeah. Mhm. And then either independent of observation, similar variance, and random sampling. Yeah, you look at the things that I just highlighted, the sampling especially. So type of t-test, there are three types. Yeah, sample t-test, compare the mean of the two groups to know value. Secondly is a sample t-test, evaluating two independent groups. Thirdly is a pair t-test. Yeah, is using the same group at the two different time points. Yeah, they have the time series maybe looking to the changing of the gender especially, or changing of the uh, two group of the people. Okay, so output of the t-test. T-test value is the size of the difference relative to variability in the sample data. A large value indicated that there is a greater differences between the groups. So degree of the freedom, DF, normally we will see the analysis, DF. DF means the number of independent variables that vary with respect to the given analysis, affect the shape of the T distribution. Yeah, so DF. P-value is a significant value we refer. So it is a probability this observed the difference in due to the change. Yeah, either they less than 0.05, meaning is have the strong differentials between the gender, let's say, yeah, or if the more than 0.05, meaning that is the no significant of the differences. Yeah. Okay, this is an example of the parity test. Our researchers wants to know if the working program reduce sorry excuse me. So for the researchers want to know if walking programs reduce the resting heart rate, okay, RHR. So they find out 50 adults are the measure to before and after the programs. So before means RHR is a 78, okay, BPM. And after the exercise, the mean is a RHR is a 72. So standard deviations of the differences is a 4 ppm. So a pair t-test is a conclude that the t equal to t.07. Yeah, the difference between the before and after RHR is large relative to the variability in the data. So if the DF, we get a 49, degree of the freedom is about 50 participants minus 1. So P must be less than 0.0001, the result showing that is a less than 0.1 chance of the result is due to the random variations. You don't need to worry. All the data, this one when you generate through the SPSS or SAS, the data will be quite similar, the T, the F, P. So this is things that we use it, yeah, to analyze, to conclude the result. Since P is less than 0.05, here P is a 0.001, so differences of statistic is very significant. Therefore, the working program significantly reduce RHR. Yeah. The other inferences statistic numerical is ANOVA. T-test is look into the pair or two groups differences. ANOVA is a more than two groups. Yeah, more than two groups. Normally we refer to the age. Yeah, age we rank it, and then somehow so we have the what educational background, also more than two groups, or type of the occupation. Yeah, okay. So this is three primary types of ANOVA. The first is so-called one-way ANOVA. It's a one independent variable being assessed. Two-way ANOVA is a two independent variable being assessed. So the third is a repeated measurement ANOVA. Same group measure the multiple time. Yeah, do remember in t-test also we have the same things. Yeah, I show you. They have the three types of t-test. Okay, first type is a compare the mean of one group. Second, evaluating the two independent. Third is the time point. Look into the same group at the two different time point. Yeah. Okay. So in the ANOVA, we do have the repeated measurement. Yeah. Okay. Same group measure in the multiple times. So in ANOVA, independent variable are compared based on their effect on the dependent variable, which must be quantitative. Yeah. ANOVA output, when we studying the analysis, yeah, they come up with a chart, yeah, the table output. Yeah, they have the GF. DF meaning degree of freedom, number of independent value in the data that vary. Yeah. Sum of squares, SS, is a measure of the total variations in the data, showing how much variations exist between the group and within the group. Yeah. So mean square, MS, is the average variables calculated by diverting SS by its respective DF. Yeah, it relates to the degree of freedom. So next is the F, statistic ratio of mean squared between the mean square within. Yeah, a large value indicate the greatest differences between the group. So sometimes we have to compare to the within the group variance. Yeah, so they look into the between the group and compare in the within the group. Yeah, I think SPSS, if you're studying in statistical analysis, the SPSS, not SPSS, the ANOVA, you're understanding the calculation. and then also t-test. Okay? P-value is a significant aspect. So since the previous explanations indicated the probability and observed differences are due to the change. Yeah. So we look into the next is the example of the ANOVA. If ANOVA significant p-value must be less than 0.05, it suggests that the less one group means the difference is significant from others. So ANOVA does not show which group differ, just the post-hoc test must be conducted. Yeah, sometimes we're running the post-hoc test. It depends. Some others are not running. Nowadays, I think student is not running the post defer to the choice of the post-hoc test. Yeah. There's a hot test like we gather the info and then we try to running it to see the any differences or not. How to identify where the specific group differ from the other group. Control the risk of the false possible disarrays from the making multiple comparison. So you look into the more than three groups. Yeah. Assumption of the ANOVA, we can use observations are independent for each other. Secondly is the normality, depend to the variable should be appropriate normality distribution within each group, or homogeneity of the variance. So variance across the group should be roughly equal, meaning it's the same understanding about the variable. Yeah. So this is an example. Yeah, we try to get it. The researcher want to know if the different type of the exercise affect the rest heart rate, RHR. They divide the 60 adults into the 3 groups. Yeah, okay, 20 adults per group. Group 1, no exercise. Okay, group 2, only walking program. Group 3, running program. After 4 weeks, they measure the RHR rate, yeah, showing the group 1, 78 BPM, group 2, 72 BPM, group 3 is 68 BPM. So the ANOVA result showing the F is equal to 0.8.24 and the F is a 2.57, P is a less than 0.001. So interpretation, your data is since the P value, significant value, is less than 0.05. Yeah. At least one group differs significant in mean RHR. A post-hoc test is needed to determine which exercise types lead to significantly lower RHR compared to others. Yeah, so they guide us to look into they have the differences or not for the group 1, group 2, or group 3. Yeah, the other one is the regression. Regression is about the continuous variable, okay, and then this is called linear regressions, and the other one is a logistic regression, is category variable. Okay, so a regression analysis predict the outcome and examine how multiple independent variable relate to the dependent variable. Okay, independent variable relate to the dependent variable. Yeah, sebenarnya lihat pada hubungan relationship. You look into the relationship. Output, they have the coefficients, symbol like B, represent the time estimated change in the dependent variable per unit change in the specific dependent variable. They show the directions and strengths in relationship. So p-value, again, to determine our significance. So this is indicate if there is a statistical significance. Yeah. Odd ratio, somehow so we have to just put on it only. They demonstrate how this odd of the outcome change with the independent variable. Okay. So in the regressions analysis, this is an example. This is a linear regressions. Yeah, a study examining how hours of the exercise per week predict resting heart rate. So coefficients like beta, okay, for the exercise was minus 1.8. Where is the p value is less than 0.01. In short, for the every additional hours of the exercise, resting heart rates are decreased by the average 1.8 beats, yeah, per minute. So per value, p-value indicate there is a relationship in the statistical significantly. Yeah. So logic regressions is a regressions models on a heartbeat disease smoker that has odd ratios of the 2.5. And then with the p-value 0.02, smoker were 2.5 times more likely than the non-smoker to develop heart disease. Yeah. So odd ratio, uh, they you have to look into the odd ratio and then the p-value. Yeah, to understanding how many percent, yeah, time more than the other one. So odd show value is important in the logical regression analysis. So for the chi-square, okay, chi-square is look into the value is more likely the significant between two the observed and expected data. So this observed and expected frequency among two category variables. Okay, 2 is x kuasa 2 chi-square. So output chi-square is about the value x2, yeah, x chi-square. That is the meaning, the measure of how much of the observers data differ from what could be expected. Yeah, a larger x2 indicate the greater differences between the observed and expected counts. So degree of the freedom, df, number of the rows minus 1 time number of column minus 1. So df normally we just show the df only, and p-value is a significant statistic. Okay? This is an example. The example of chi-square is a researcher want to know the associations between the exercise exercise habit, and the exercise regularly versus does no exercise, the heart disease status. So exercise, heart disease 10, do not exercise, heart disease 30. Okay? Okay, no heart disease is a 40 for the exercise and 50 for the exercise. Yeah, total 50 respondent. So for the does not exercise, heart disease 30, and no heart disease 20. The total respondent is 50 also. So chi-square test provide the x2 equal to 6.63, df equal to 1, and p equal to 0.01. So interpretations, since we look at the p, p is significant, okay, must less than 0.05, a conclusion can be made the exercise habits are significantly associated with the heart disease status. Okay. Okay, this is a list of the selected tests and the fit to the type of the analysis. So we look at the first is the Pearson correlation coefficient. It's a two continuous variable. Yeah, we look into a correlation analysis hubungan. One sample t-test when it's a continuous data. When you have one group and are comparing it to an average. Okay, we're comparing the average, yeah, one group compared to other. Independent t-test, okay, data system continuous. So when to use is when you are comparing two separate groups. Okay. Pair t-test, the data also same, continuous. And then When to use is when you are measuring one group twice. Yeah, we're measuring one group twice, so we use pair and pair t-test. For the one-way ANOVA, when you're analyzing means a more than two groups. Yeah, okay. And then two-way ANOVA is when you're analyzing the mean of more than two groups and have the two independent variable. Okay. Repeated measurement ANOVA, when you are evaluating the same group at a multiple time points. Okay, it's quite similar to the pair t-test. Yeah, pair t-test is looking into twice group, two groups. Yeah, here is a more than two groups in the series of time. Okay, linear regressions is a model relationship. We can build out the model, yeah, to become a mathematical model. Yeah, okay, linear regressions and logical regressions when we have the binary or dichotomous variable. So chi-square test is a category, and then we try to compare proper proportions. Yeah, compare the rate between two groups. So in analysis of the statistical, sometimes we got headache how to present the data in a good way. So the result must reflect, yeah, numbers, statistic. You can use the table, chart, and graphic. Report descriptive statistic, mean, SD, frequency. Report the interference statistic, t-test, ANOVA, regression correlations, and provide exact value P, the effect size, and confidential interval. So any types of the analysis, you just cut the result from the SPSS and then try to try to summarize, try to elaborate. Yeah, for example, there was a significant positive relationship between the caregiver stress and behavioral challenge. Yeah, P less than 0.1 and R is a 0.62. Yeah, but you have to try to avoid. The result shows the caregiver are very stressed. Interpretation too easy. Yeah, you have to go to your hypothesis, like example good, and then highlight the P is how big, the value of P. Yeah. Next is interpret the result critically in the discussion. So sometimes external examiner or internal will say, "Hey, why too plain your data analysis?" And then you should explain why the result happened. Yeah, either positive or negative. Yeah, compare with the past literature. Sure, we have to compare in the discussion. Identify whether findings support a contradict previous study. Yeah, relate result to the theory or the conceptual framework. Bring back to the problem statement. Yeah. Mm-hmm. So that example for this, the strong correlations between the caregiver stress and behavioral challenge inconsistent with the Smith ETAL 2022, who found the caregivers of the ASD, yeah, autism disorders, children tend to experience higher emotional burdens due to the limited social support. Okay, this is the way he explains, yeah, relate to the previous. Yeah, either the previous have the contradict or the similar. Yeah. So any question? Yeah. Quite bored, yeah, today. Yeah, because it's a statistic analysis. Yeah. We have the exercise. Later on, I will, okay, the assignment. Yeah, assignment from my side is about 15 marks, but I give you all is a two. Yeah. Okay. This is the assignment. Okay. Assignment is assignment one is a qualitative result and discussion, where the case study background, a researcher conducted a qualitative study on the experiment of the parent with the autism children in rural Malaysia. The researcher interviewed 12 parents using the semi-structured interview and identified 6 primary themes. Yeah, okay. They divided 6. First is a late diagnosis and screening challenge, emotional stress and uncertainty, limited access to the therapy services, strong reliance on the informal community network, financial burden and job descriptions, and how the better government support hope for the better. So, however, the researchers struggle to produce a rigorous result and discussion chapter, especially in the organizing teams, support teams with the evidence, integrating the literature, and addressing the trustworthiness and the reflexivity. So this is a scenario. Yeah. The question for assignment one, as a researcher consultant, yeah, criteria evaluations the researcher of primary teams and develop on the improved structure for the qualitative result and discussion chapter. Yeah, okay. So this is a 15 mark. Your answer must be reorganize the team framework for the improve the clarity and logical flow. Secondly, is a specific example of how quotations should be used to support teams. So you try to Google to get a quotation to try to coding and a discussion strategy that connected finding to past literature and theory. So your discussion must be have this, and then suggestions to enhance the credibility, uh, uh, trustworthiness, yeah, number of checking, reflexibility, and so on. And then the final synthesis, the interpretation, explaining the border meaning and implications of the finding. So you try to come up this for me, okay? I think the submission is before 15 December or 22nd December. Okay. Later on, I will send the Google link, folder link to the doctor, the CGS. They will share with you all. The project must be submitted to me, yeah, or when I think before 22nd of December. The second case study is our quantitative analysis. Okay. For a quantitative analysis, study examining the relationship between the teacher's readiness, X1, and the school support, X2, and then the inclusive class effectiveness, Y, in 20 secondary school in Johor. Yeah, this is a data analysis produced the following result. Mean score of the teaching readiness is a 3.12, SD equal to 0.44. Mean score of school support is 0.89 and SD is a 0.5. 0.57. Regression models are equal to 0.62. So teacher readiness is 0.48. It's less than, and then the p-value is 0.01. Okay, school support is value p is a 0.01, 0.04. So no significant differences between the urban and rural school. Is a p equal to 0.281. So study use a self-administrated Likert skill questions. So researcher is unsure how to write the full result and discussion chapter that is academically strong, aligned with the research questions and theoretical support. So your rule is using the statistic result above, construct the comprehensive and academically sound quantitative result and discussion section. So I give you some guideline. Your analysis or your result must be proper reporting the descriptive and inference statistic in academic format. Secondly, interpretations of the relations result, explaining a strain and significant and practical meaning. And then critical evaluations of the why urban and rural differences are no significant. You try to give the answer. Okay. Integration with the past literature. Okay, you have to coding. Yeah. Do remember this is a way we analyze the result. Yeah. You have to code and then again relate with the support literature review. And then theory implication, because this is a quantitative, you must relate with the theory. So link to the teacher readiness theory or inclusive education model. Yeah. Okay. Relate it back to your theory and practice recommendations for policymaker and school. And last is the limitation and the future research direction. So here is a so this is a what? This is a question. Yeah, you can later on I will pass it to the group into the group, or I send it here. Okay, I think I can try to understand it. Okay. Okay, thank you, Doctor, for everyone. And then Shafinas asked me the question one. Can you please explain again? Okay. Okay, I try to share again the question one. Okay, question one. This is a study for the autism, and then 12 parenting. Yeah, parents are identified, and then you already identified 1 to 6 primary teams. So your work is what? Recognize the thematic framework that improve, clarify the logical flow. So your work, your analyze must have this. Yeah, reorganize. Yeah, maybe restructure. Maybe everyone's result is the differences is no problem. I want to see how to organize it. Yeah, with the what? With the support team. Yeah, like support teams. Like what is the first element? Late diagnosis and screening challenges. Maybe this is about the social stigma. Maybe this is due to the some information lacking the knowledge or awareness. Yeah, this is maybe the sub theme can help. Emotional stress and uncertainty. Yeah, this is maybe they have the other sub themes can support. Yeah, you restructure again the team. So a discussion strategy that connect the finding to the past literature and theory. So you try to Google to get the past and then your explanation must be there. Yeah, based on the Tawisel 2019, the study shows that this is the uh, what support our finding, uh, blah 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 blah. Or you can get the other way. Yeah. Okay. So suggestion to enhance the credibility and trustworthiness. Yeah. So you can come up with some suggestions. Yeah. Mhm. So a final synthesis interpretation explain the border meaning and implication of the finding. So for this, maybe your finding will be put on what the change of the policy. Yeah, look into the larger scale of the spatial education for those with the autism and so on. Okay, it's a not it's not difficult for me. Sure. I think once you understanding what is the qualitative, what is quantitative, this is just a guidance. When you have the data, is the same way you analyze. And this also, yeah, and when you have the data, is the same way you try to analyze it. Yeah. And then you try to explain with some research study, previous research study, either the contractive or either they are in the okay. You don't worry about the statistic analysis. Yeah. Mhm. You don't worry about because we have the uh, software to running your SPS. You're running your data. You just key in, and then you can get the full data. Yeah, in the set with the TF, with the P, with the other, and then you just explain it. Yeah. Uh, Important things is your value P. Yeah. Okay. Okay. Later I will share the document. I think share it here or share it where? Yeah, it's okay. Any questions?
Prof,
Yeah.
how many pages for both assignments?
Oh, how many pages? I think 1 page is enough for one, right? Or 2 pages for one is okay.
All
It's
right.
up to
So
you.
including the references?
Sometimes, yeah, you can include. Yeah.
All right. Thank you, Prof.
Okay. I think maybe for these two assignment, you can make it less than 5 pages. Yeah. Maximum is 5 pages. Yeah. Okay. Any question? Yeah. Lisa? Okay. How can I like share the document here? Yeah. Can we share the document in the chat room?
You can share the link of the document.
Oh, link the document. Okay. Wait. This is attendance. Yeah. I think later on I try to come up with uh the document link. I think, or better, I share it. So how about the other lecturer? They share through the CGS or what? Okay.
Previously, they give to Dr. Hadila, and then
Okay.
Dr. Hadila will send the documents to us.
Okay. Good. So I will using the same one, and then maybe CGS later on can help me to create the folder for the student, all the assignment inside there, and easy for me, yeah, to get access. Yeah, Dr. Hadila. Okay, thank you, Dr. Hadila. Okay, yeah. Because the document, although this document could be kept by CGS later on for the audit purposes. Yeah. Okay. Any questions? All the best. Yeah. For all of you. Yeah. Today is quite because you never you haven't go to the journey of the research. Go to the chapter 4. Because chapter 4 and chapter 5 of the research is analysis. So you can't imagine. Yeah. Mm. If maybe you already have the experience during your undergraduate or master level. Okay. Mm. I suggested that you try to read more, your document or thesis, and then you get a more understanding about how to interpret the data. Yeah. I think along the journey for me for the PhD, I think the words is during the data collection. Yeah, yeah, you've taken more times, and then when you build out the proposal, so develop the proposal is taking more times. Once the data is in your hand, I think it's easy for you to run the analysis. Yeah. Again, for the qualitative analysis, sometimes we don't have the standard how many respondent that you need to have, but normally when the data collections is come to the certain level, the result is quite similar from the everyone, then you can stop, yeah, to do your data creation. But have to make sure your data creations must cover all the stakeholders that you in your plan. Yeah, if not, you just go to the one stakeholder. Maybe is sure one stakeholder, one type of stakeholder, they will get the same data. Yeah, and then you may have the proper what arrangement and then the planning for your data creation. Yeah. Okay. Wait a moment. Okay. If no questions, I end up this section, and then I hope that everyone can pass your assignment before 22nd. Yeah, as the due date set by CGS. Okay. Have a good day. Sorry, today I'm not really not very good in health. My voice now also not very good. Yeah. Okay. Thank you. Yeah, and all the best. Yeah. And time to time, you can come to the faculty or email me about your issue and problems. Yeah. Thank you, Muji. Yeah. Shafina's due date is on 22nd December. Yeah. Thank you. Annie. Yeah. Okay. All the best. Yeah. Okay. Thank you. Yeah. Thank you, everyone.
Prof.
Yeah. Okay. Thank you.